Okay, so my talk is about Go and Rust. I'm Barnaby, by the way. Probably should have done the intro first. That's my socials and stuff. Yeah, so my talk is about Go and Rust being combined in a sort of new way. I hope this will be informative. It has a bit of a disappointing ending, but there is light at the end of the tunnel. So hopefully you learned something, and hopefully you are encouraged to contribute, because these are projects that are ripe for contribution right now. This image was generated with OpenAI. These are all the failed attempts of generating images with OpenAI. Some of them are quite funny. Some of them are, this one looks like a kid's drawing. Yeah, but it's good for making talk slides. So anyway, I have no idea. It kept generating crabs and gophers. I don't think I know what gophers are. Anyway. So the challenge that I'm going to be talking about is cross-platform extensions. So essentially the product problem that I have is I'm building a piece of software that I want to ship to customers that they self-host, and I want to facilitate third parties for creating extensions for that software. Now, the security conscious people in the audience here are probably, the alarm bells are going off right now. Running untrusted user code on your customer's software, that's full of pitfalls, right? So this is a difficult problem to solve, really. So we want something that's easy to host. We don't want to be doing, releasing multiple binaries and running separate processes and all that sort of stuff. We want to be able to run it in a container, on a server, anywhere, right? We also want to make it easy to work on. So we want it to be pure Go. We don't want to have any C bindings, and we want it to be fully cross-platform. So somebody with a Windows machine can run it, somebody with a Linux machine can run it, somebody with a MacBook can run it. Anyone, right? So again, OpenAI. I love the ones with sunglasses. They're great. So that should be bigger, but hey. Language agnostic extensions is the challenge. And we want to be building a product in Golang that's extensible. We don't want to force customers to build it from source. We don't want to give them the source code and be like, oh, turn on these build tags and you'll get these features, because that just makes it really difficult for third parties to build things. And it also means customers who don't know Golang or don't have engineers that know Golang, or people who just want to run the software who don't know Golang, they have to then learn how to use the compiler, which is not ideal. We also want it to be safe and secure and sandboxed. Security is a big issue with things like this. So we don't want people to just be like executing commands, even if it's in a container. As you probably know, there are many ways out of a container, maybe less so nowadays, but still, you don't know what you don't know. We also just want it to be simple. We don't want to have all sorts of weird tooling, command line tools, all that sort of stuff going on. So, and we also want plugins written in Rust, hence the title, because we want to bring the Rust and the Golang world together. So, how do we solve this problem? There's a few solutions out there before. I was talking to someone earlier about Golang plugins. They are terrible. They don't run on Windows, so that one box isn't ticked. The API is really mid. You can't probably read this, but you open a plugin, you find a function with a string name. Again, there's an opportunity to write a typo, and then that's confusing. And then you have to do like a straight up type assertion. If it goes wrong, the compiler can't save you there. You find out at runtime. Another solution is cross-process RPC. This is another fancy way of saying network calls, so an API. A lot of programs, or a lot of software, SaaS products nowadays do this. The biggest one that you've probably all encountered is Slack. Slack does extensions via an API. The downside here is if you want to build an extension for Slack, you have to host the server somewhere, which means if you build a plugin for Slack and then you go bankrupt, your plugin disappears. No one can use it. So all the people who were using it before suddenly lose access because you have to host it. Another one is you could get people to self-host it, but that's more like pain. Another way of doing this, which I've seen quite a few pieces of software do this, and I've written something that's done it before, is have an embedded interpreter inside your software. So this is effectively like a Otto. If you've used Otto, it's basically a pure Golang JavaScript interpreter. Unfortunately, it only supports like ES5, I think, and you can't use NPM or Yarn or anything like that. It's basically just for like really tiny data manipulation scripts and stuff. So yeah, there's also another embedded shell interpreter. If you like POSIX shell, then that, I don't know. I don't like shell. I think it's really hard to read. But if you're into that, you can do that. But again, you can't really kind of pull together an ecosystem of tools to build your extension. You can't just make a HTTP call. You've got to make sure the person has like curl installed, and it's a nightmare. They offload the complexity onto the end user. So it's a little bit of a problem, and it doesn't really solve the problem in the way that we want to solve it. So the solution here is WebAssembly, or at least I hope it will be WebAssembly, as you'll find out. The write once, run anywhere. If anyone's heard that phrase, you know the history of Java. I think it's kind of making a resurgence, but it's taking a while. And maybe it's a Sisyphean task. Maybe we'll never achieve it, right? Everyone's trying to write cross-platform things, React Native, Flutter. I don't know. I'm not convinced yet that there is like a write once, run anywhere, but we can get pretty close. So what does this actually mean for Golang and Rust? Well, the goal is you write a Go program, which is a piece of software that you deploy to, customer servers or, open source or whatever, and then people can write plugins in Rust or assembly script or JavaScript or Golang or anything, and you can run it inside the software. So when doing the research for this, most of the use cases for WebAssembly out in the wild, so like actual products using them to make money, I only found one, and that's Figma. So Figma, their front end is built in C++, I think, maybe a bit of Rust. They compile it to WebAssembly, and then they run the WebAssembly in the browser. So WebAssembly, the main use case that's kind of, the primary force behind the tool is running stuff in the browser. But under the hood, WebAssembly is actually really interesting. If you're a bit of a computer science nerd and you like, instruction set architectures and all that sort of stuff, WebAssembly is a really kind of fascinating thing. If you've done a computer science course, you probably did a whole module on Harvard architectures and von Neumann architectures. Von Neumann, I'm not entirely sure how you say it. But all computers, von Neumann architectures, that's just the way that we build systems nowadays. That basically means that all your code and all your data live together in the same memory, which is how you end up with all this like weird security issues with languages like C and C++, because you can just read to the end of a string, and then if the string doesn't have a terminator, you just keep reading, and then you start reading code, and then you can write code, and then you can change the behavior of the program while it's running, which is why Rust exists, partially. Because in Rust, you can't do that in theory. You can, but you have to be, pretty clever. And I think there has been a few out of bounds like bugs in the compiler and stuff, but for the most part, it does a really good job of preventing that kind of problem that C software has been plagued with for decades and probably will be forever. But the way a Harvard architecture works is it separates the code and the data into two separate memory sections. I'm not going to go into this like too deeply, but if you're into that kind of thing, like low-level stuff, I would really recommend like reading about WebAssembly and how it is implemented, because it's really interesting. So what actually happens is WebAssembly is effectively a like virtual CPU. So it has a fake sort of virtual instruction set, and you can, in theory, you can compile any program in any language, assuming it has support, to this virtual instruction set. And that means if you have a host program that supports executing that instruction set, then you can run that software in a secure environment-ish, assuming that the implementation is secure, and then you're back to that problem. But the hope is that you can create an isolated environment, similar to containers, but instead of containers running on an operating system, you've got containers running inside your application, which means you can call into them and you can call out, you can call callbacks, you can move data around and stuff like that. Sounds a lot like an extension or a plugin. So another box that it ticks for the problem we're trying to solve is you can distribute your plugins with a single file, which means you can create a marketplace, you can create an ecosystem, you can download them from GitHub, you can do whatever, right? Because it's just one file, that's really simple. So what does it actually look like if you're writing a Golang program and you want to host plugins written in WebAssembly, which, you might write the plugins in Rust, hopefully, being the crowd. So the runtime I came across, and the one that I've been using the most over the past few months of building this project, is called wazero, W-A-0, wazero, I guess. So this is called wazero because it's a WebAssembly runtime with 0 dependencies. It's written in pure Go. There's quite a few of them out there. They're written in Rust. You probably know there's crane lift, there is wasm-time, there's quite a few. C++, C, Rust, all written in these languages. This one is written in pure Go, which is great because it means we can run these plugins without having to depend on C code or Rust code. Sorry, for Rust people, I want my Rust to be embedded inside a wasm binary. I don't want to be passing CGO flags to my compiler. So the problem here is that the host code is quite boilerplatey. There's a lot of stuff you've got to do to declare one function. You've also got to do manual memory management, which is a bit of a nightmare. You don't get like lengths and stuff to read buffers from. You just kind of read them until you get to a 0. There's that problem again with terminated strings. And another problem here is there isn't really a standard yet. There is a WebAssembly system interface, which is like a proposal around like standardizing how we do things like function calls and all that sort of stuff and interfacing with the system. So like file IO and networking, but it's still kind of in the early stages at the moment. So yeah, you've got to do some manual memory allocation sometimes, which is fine. As long as you don't have to get the person writing the extension to worry about that, then it's fine. There's another library I did come across called WAPC, which I assume stands for WebAssembly Procedure Calls, kind of like RPC, but I couldn't get to run. So again, there's a lot of this tooling isn't really mature enough to be just jump in and use it in the same way you can sort of grab the Go compiler and start writing Go code immediately. You grab the Rust compiler, you can start using Cargo immediately. There's a lot of weird issues with these that you run into, you Google the error, 0 results. If you've ever Googled an error and got 0 results, then my heart is with you. I know how it feels. It's terrible. So, but there's opportunity for contribution. And if you're into that sort of stuff, then there'll be a slide at the end of like where you can go to sort of like get more involved. So what does it look like for guests? So the terminology here, guest means the program that is the plugin. So it's the program that third party has written, hopefully. So with Rust, you kind of write it as if you're writing C bindings for Rust. You've got this sort of pub extern C saying export this function, and then no mangle means don't mangle the name, don't give it a bunch of weird prefixes and parameter-based naming and all this weird stuff. If you've seen mangled names, they're a nightmare to read. No mangle just means if I call it on post created or create, then that's what I can search for when looking into the binary when I want to call that function. One problem you might have noticed here is I have a constant unsigned 8-bit and then a length, which is an unsigned 64. That looks very much like a C string because it is a C string, basically. It's a pointer to a position in memory, and then it's a length of how to read, how far to read until you get to the end. So we're kind of getting a little bit out of where Rust should be, which is worrying. But there are solutions to that. So when you want to like actually write a plugin that works with this, you can't just write Rust code, which is kind of annoying. You've got to have domain knowledge about where the program is going, which you could argue you have to do if you're writing a DLL file or like a shared object for Linux. When you're writing like plugins for other software on the operating system, you have to do the same thing. So it's not that bad. It just means that you have to document it. The problem with WebAssembly is it only deals with integers. You can't really it's really hard to work with objects and arrays of things and strings and stuff, especially when crossing the boundaries between the WebAssembly program and the host program. And this problem applies to the web browser as well. So when you're writing, code that's going to run in the browser, you run into this problem as well. And you have to like generate bindings in JavaScript that then sort out all of this like memory kerfuffle, right? Yeah. Bruno knows this pain. He wrote a really good blog post about ImageWand, which is a browser extension that uses WebAssembly. It's a really good read. So yeah, there is a slightly more standardized like ABI that's trying to kind of like gain traction. And it says WAPC that I mentioned earlier. They're trying to standardize like an ABI, an application binary interface. They'll probably call it WABI because the WebAssembly like trend is to just put W at the beginning of things, and there you go. So AWI, WABI, I don't know what they're going to call it. So it uses a kind of gRPC-like IDL, so an interface definition language, where you effectively describe in a declarative format what your function calls look like, and then from that it generates code for both languages. Well, it generates the code for the Golang side dynamically during runtime, and then at the other end of things in the guest program, you have a bunch of like generated stubs basically to like talk to the host program. And it seems like a pretty good solution to the problem. It handles all of the explicit memory management for you, handles all of the sort of cross-domain stuff, and you end up with a fairly nice interface. In Rust, it's typically a set of traits that you just satisfy using, the code that you want to write. Then it works. The problem is I couldn't get it to work. I tried it on a Windows machine, tried it on a MacBook, didn't bother with Linux, but I gave up at that point. So it looks like a really good solution to the problem. And they officially support Golang, Rust, AssemblyScript. For those of you that don't know, AssemblyScript is like a TypeScript-like language, but it specifically targets WebAssembly. So they have types like U8 and U64 and string pointers and stuff like that. So it looks like TypeScript, but it's actually a low-level language. It's pretty cool. But yeah, so I think WAPC, however you want to say it, it's a promising project. It's actively developed. And if you're into that kind of thing, definitely want to like poke around issues and pull requests and maybe try and contribute. So I'm hoping this one becomes more popular, and I hope it gets sort of easier to use because it's really cool. And this is what the Rust code looks like that it's generated. This isn't generated code, this is code I've written, but it's using sort of like the like imports and stuff that it provides. So we have a non-mangled function as usual. We don't have to use extern-c here. I actually can't remember why. But you register the function, you give it a name, you've got to be wary that you don't make a typo. And then you have this return type, which is call result. And the way that this works is it will call your function, then your function will call a result back into the host, which will set up some memory to store the result. This is all generated, compile time. And then it'll call back into the WebAssembly, and then everything is ready to like write data between the two worlds, which is great because it means you don't have to worry about memory management and allocating buffers and all that sort of stuff, because you do actually have to do that on the host program still, which is really weird for Golang. Talking about Golang and allocating memory. It's a garbage collected program, so it's a bit of a weird idea to like combine with that. But in terms of user experience and like developer experience, this looks pretty good. Once you've defined your kind of IDL and you know what your data looks like that's going in and coming out, then you can basically create a spec put that spec on your website, and then developers who want to build plugins for your system, in theory, can just grab that spec and generate all the code they need. It's kind of like OpenAPI or like gRPC, protobufs, that sort of thing, but for WebAssembly. So it's a really promising idea. I just couldn't get it to work. So that's the kind of dream. Unfortunately, I didn't actually get any of this stuff to work to a point where it was like something I'd ship as a product to people. So for now, it's basically just, we'll use an API like everyone else. But I think there is a future here. I think there is a future for WebAssembly outside of the browser. And there are other people working on similar solutions to this problem. So it's definitely something to like keep an eye on. If you have the sort of problem that you want to solve, then this might be the solution. So the good parts, in summary, it's a dumb thing from OpenAPI again. In summary, it's a good way to run untrusted code, assuming the runtime is audited and works. At the moment, I don't know if any of the WebAssembly runtimes are audited apart from Google Chrome's V8 like WebAssembly runtime that runs in Chrome. That's something you have to be wary of when building things that you're shipping to customers, especially if you're a business, which this project isn't yet, but it may become that. You've got to be wary about making sure things that you're running on customers' machines is going to be secure enough, especially if they're running untrusted user code. But it's really interesting, the idea that you can build extensions in any language, kind of. So the problem here is that you have to do some work for each language to get it to work right. And the reason you have to do that is because there isn't really a set of standards in place yet. So the WebAssembly system interface is probably going to solve like 98% of those problems. But we'll see. There's still issues around sort of like what the guest code looks like and educating people about like how to write that stuff. So it's kind of all up in the air still, but I think it's promising. And the actual WebAssembly bits, surprisingly, they're quite simple. Compared to like virtualizing operating systems and containerization and all of this stuff, these are all really complicated problems to solve, and there's a lot of smart people working on them. And Docker kind of changed the system landscape when it came about. Kind of was an alternative to like, you know, virtualizing an entire operating system. Interestingly enough, literally 2 days ago, Docker, the company, actually announced that they're going to be starting to provide WebAssembly natively in Docker. So you can take a WebAssembly binary and you can run it like a container. So this world of like containers and applications and operating systems is kind of converging into one thing, because you don't really need an entire Linux distribution running just to run your application. And if you can compile your application to a single WebAssembly binary, then that's kind of, if you squint, it looks very similar to compiling your application or building your application plus an OS into a container image that you then just ship and run. So yeah, again, I think there's some future here. And there's definitely some big companies with lots of money making a bet on WebAssembly as being like potentially a way to run serverless applications at the edge. Because WebAssembly applications are, assuming we get WebAssembly system interface like working and everyone implements it, then it definitely looks like a way that you could distribute applications. And yeah, so I think there's something there. So the bad parts, there's definitely a lot more bad things that I ran into while doing the research for this talk and doing the research for like this feature of the product. There's a lot of boilerplate. It isn't really that bad to have boilerplate in the host program, because it's your team that's going to be writing it, or it's going to be me that's going to be writing it. It's fine. If I can make a good user experience, that's what matters most. And I will sacrifice a few more hours to do that. But boilerplate in the guest program and having people who are writing Rust have to learn how to not write Rust in like an idiomatic way, that's kind of problematic. So it hurts developer experience. And in part, if you're trying to build a plugin ecosystem, if you're trying to build a product that's kind of like Shopify or Slack or Discord, where it basically lives and dies on the ecosystem of extensions and bots and plugins and stuff that other people build, then it's really going to hurt, right? All of these products I just mentioned, they have really good documentation, and you can read a tutorial and you can build a plugin or an extension or a bot or whatever they call it in a day, which is really powerful, because then you can take an idea and be like, oh, I want to build like a polling bot for my favorite League of Legends champion. You can do that. Or you're like, oh, I want to build a bot that scrapes all the chat and then trains an AI on all my friends' chat messages. You can do that with Discord. It's pretty cool. So it's about making it easy. And I think WebAssembly is almost there, but it's not quite there. So WebAssembly, system interface, and APIs, I keep saying that. I think that's really the crux of this whole problem. If you solve that, then all the other solutions, all the other problems kind of get solved as well, mostly. Another weird thing about that is the fact that if you write a plugin and you want to make a network request, that suddenly becomes really complicated, because the WebAssembly system interface doesn't currently expose any socket interface. So you have to provide that from the host. And if you provide it from the host, then suddenly all of your libraries like requests or Python's requests library or JavaScript's like HTTP library, they all won't work, because they're going to be trying making system calls, not whatever API you've built. But it is coming. It's just taking a while. But it also means that you can intercept those calls from the host program. So there's a little security benefit there. You can make sure that it's not doing things that it shouldn't be doing. So, there's something there. So writing this talk was disappointing, because I wanted to solve a problem and present the solution to that problem. And instead, I ended up presenting a bunch of dreams. Some of them were broken, but it's fine. I think there's light on the horizon. And I'm not just saying that because I wanted to write a talk that had a happy ending. But I think it's early days of WebAssembly. The idea itself has only been around for like not even a decade. So there's also good ideas out there. There's lots of competition. So there's wazero, there's wasmtime, crane lift. There's quite a few implementations, and they're all kind of competing and trying to build like different ways of kind of approaching the same like solution. So the best part is that everyone in this room can help. Regardless of your like experience level, I think that there's something out there that you can maybe like try, even if it's just trying to build something, failing, reporting an issue, and helping like improve the whole thing. I think is it's all possible. And if you're into kind of sort of more low level type things like system architectures or instruction set type stuff, WebAssembly is really, really fascinating as like a computer science topic. It's really cool. So jumping into that and learning it, it's quite simple. Like it's way simpler than like the ARM architecture or the Intel IA64, whatever it's called. So it's a good thing you can read and understand and nerd out about. So how can you actually contribute? So wazero is the thing that I've been using the most. I chat to the guys on Slack. They're really friendly and really helpful, and they have a website, and they have a channel in the Golang Slack as well. So you can go there, you can ask questions, you can contribute, you can go to the GitHub, and you can figure out this WAPC thing. That one's really cool as well. That is actively developed. Even though I couldn't get it working, I think it's very promising. So I'm definitely going to go there and see if I can like figure out what my problem was, what the solution is, and maybe make the experience better for the next person. There's also the WebAssembly component model, which is that's a proposal that's open for comment at the moment, and that's effectively solving the IDL thing, where you have a function and you want to pass an object with like maybe a name and an age and a bunch of forum posts. The component model is kind of a solution to that. It's effectively a way for like encoding objects and more complex data structures than just integers, which WebAssembly currently only works with integers fundamentally. So yeah, there's that. And just general Golang WebAssembly stuff. You can go to the WebAssembly channel there. Sorry for the Rust stations in the room. I don't have an equivalent page for the Rust side of things, but I'm sure if you want to like, figure out how to like get a Rust program running in WebAssembly and run it in a Go program, then these places will be a good place to start. So that is the talk. Hopefully it wasn't too disappointing, and hopefully there was a good ending where you can contribute and learn and be part of this new technology, which seems to be like a new way of doing things, maybe. But yeah, thank you. And thank you to the Golang organizers and the Rust organizers. Take questions.
Does anyone questions? Let me just get the second microphone. That one.
Yeah, I forgot about questions. Good point.
Hello. Yeah, I had two thoughts. The first was, is Golang not supported by WASMA? Because you had it there and crossed out. And the second thought was the boilerplate side of things on the guest, as you mentioned, was a pain point. Have you thought about maybe distributing a sort of simple library SDK style thing to make it easier?
Yeah. Okay. So the first thing, Golang is supported by WASM in the sense that you can take a Go program and you can compile that Go program to WebAssembly, which means you can get a Go program running inside a WebAssembly runtime, which means you can run it in the browser, or you can run it in Docker's new WebAssembly runtime thing. But there's no official support for Golang as a host for WebAssembly programs. But that would be a cool thing to do, to be able to basically write a Golang plugin in Golang and then run it inside another Golang program, but as a WebAssembly binary, which still solves a bunch of problems, right? You've got this safety problem that's solved, you're not running untrusted code, and you also have a cross-platform runtime that runs on Windows, Mac, and Linux, and you're not using the weird Golang plugin system. So yeah. What was the second question? Sorry, just remind me. Oh yeah, the libraries. Yeah. So yeah, that is a solution. Basically, you write a library in each of your target languages, which is kind of what WAPC has done. So they support, off the top of my head, I think Golang, Rust, assembly script, and something else, but I can't remember. But yeah, you can do that. The problem with that is that if you're an individual working on a side project, side hustle, or a small team, that's a lot of work, and it scales linearly with the amount of languages you want to support. So you want to support Ruby, you've then got to write a bunch of Ruby bindings, which also means if you're not a Ruby programmer, you've got to learn a bit of Ruby and how that works. Same with like Python, JavaScript, all the other languages in the world. So I think that work will have to be done anyway. Yeah, you will have to at some point get some people, right? But if you can standardize the inter-process communication with like a standard way of doing things, then it becomes easier then, because it's not all in one person's head or one team's like design document. It's open and open source, and everybody can do it. So yeah, thanks for the question. So any more?
Yep, I'm here. So asking from a perspective of someone who's never written any WebAssembly or anything like this, when you say it only works with integers, do you mean like it doesn't even have like IEEE floats or?
Oh yeah, sorry. Yeah, it works with floats and integers. Yeah, sorry. Basically, like very small scalar values it works with.
But it doesn't have a way of like representing structures and.
No, it doesn't have a way of doing structures or arrays or lists of things. Effectively, WebAssembly itself is quite low level. But with those very fundamental building blocks, you can get to a point where you can represent strings and objects and stuff. The problem is there's no standardized way of doing that. So if you wanted to pass a string to a function, so I built two proof of concept programs with this. One of them was written in Rust. One of them was written in assembly script. The assembly script one called my function with a pointer. That was it. And all I could do was read from the pointer in memory until I got to a 0, which signifies the end of the string, like C strings, basically. When I did the Rust version compiled to a basically machine code, well, WebAssembly code that had a pointer and a length. So there's differences in sort of how different compilers like generate code, basically. Some of them will give you a length and a pointer. Some of them give you a pointer. Some of them might do something else, like it might be a Pascal string where the length is first and then the pointer is afterwards. So because there isn't really a standard yet on like how this stuff works, it's a bit more complicated, but they are in progress and they are happening. So we will end up in a point hopefully soon where there is a well understood way of doing this stuff. It's just kind of one of those situations where they built a bunch of very simple fundamental tools and then just said, okay, here's a bunch of stuff, go wild. Think of all the crazy ways you can do things. All the bad ideas will die and all the good ideas will survive, hopefully. So yeah. So any more questions?
Take one more question. There we go.
Nice throw.
Hey, thanks for the talk. This is a quick one, really. When you are loading a third-party plugin, you're doing this call, and if the third-party plugin is, say, written in Rust and it panics or crashes or does something illegal, does that bring down the whole process?
That is a really good question. No, which is really good because it means that your host program isn't kind of at risk of being taken down by a third-party plugin. I think now that's the problem, right? You're trusting the runtime to do its job, right? But that's just part of like the open source world, and it's part of like software, and it's part of building things as teams. There might be a bug in the WebAssembly runtime. There might be a bug in wazero, and you never know if you're going to hit that, right? So you still have to kind of write your host program under the assumption that something might go wrong. Luckily with Golang, like you, as long as you can, like, you put a recover, you put a retry, you should be good, as long as it's not going to hit some kind of like catastrophic, like, memory thing. But then again, that's more of a Go problem than like a WebAssembly problem. If you can take down a whole Go program without recover running, then you found a bug. So, but yeah, good question. I think it should be fine in wazero. But yeah,
I guess you don't know anything about how that's implemented, because I thought they just ran in a single process space and you could dereference invalid memory and kill the whole thing. But if it's interpreting the dereferencing somehow and intercepting it, that wouldn't be a problem.
Yeah. So basically, the wazero is running in the Go process, and it's accessing memory, but all that memory is managed and implemented by fundamentally a Go program. So WebAssembly never talks to the underlying operating system. WebAssembly never like allocates its own memory, or the pointers it's working with are pointers in WebAssembly world, not pointers within like Linux kernel world. So when I say pointer in WebAssembly, it's like a sandboxed pointer rather than like an actual pointer.
Makes sense.
Yeah. Thanks.
Great. Thank you very much, Paul.
Thank you.